Day 4, factoring polynomials. Today we use the factor theorem to determine whether linear binomials are factors of polynomials. The factor theorem states that a polynomial f of x has a factor x minus k if and only if f of k equals 0. So if you take your k and plug it into your function for x and solve, if you get a remainder of 0, then it is a factor. Let's look at this example using direct substitution. So they want us to determine whether x minus 2 is a factor of f of x equals x squared plus 2x minus 4. So if we take x minus 2 and set it equal to 0 to determine what x equals, we can then evaluate our function for f of 2, meaning you're plugging 2 in for all of your x's. 2 squared is 4. 2 times 2 is 4 minus 4. 8 minus 4 is equal to 4. So f of 2 does not equal 0. So x minus 2 is not a factor. The only way it can be a factor is if you get a remainder of 0. So let's take a look at this using synthetic division. So synthetic division is often a shortcut to determine whether things are factors, because sometimes the numbers can get very large if we're evaluating. So x plus 5 equals 0. Subtract your 5 so you get x is equal to negative 5. So for our synthetic division, in our magical box is going to be a negative 5. Our first, remember you're going to take the coefficients of all of your terms, and if you're missing terms, like we're missing an x, we want to replace it with a 0. So we have positive 3, positive 15, negative 1, 0, because we don't have that linear term or that x, 25. After your last term is when I draw my bar for my remainder, and remember we want this. If 0, it is a factor. So synthetic division, we drop our first term, multiply, negative 5 times 3 is negative 15, and then we add. Multiply, 0 times negative 5 is 0, and then we add. Multiply, negative 1 times negative 5 is positive 5. 0 plus 5 is 5. Multiply, 5 times negative 5 is negative 25. So we get a remainder of 0. So we can say that x plus 5 is a factor of our polynomial. So example 3, they ask us to show that x plus 3 is a factor of our function and then factor your function completely. So we set our factor equal to 0 to get our x. We plug our x into our magical box for our synthetic division. We make sure we have all of our terms. We're missing an x squared, so we're going to replace a 0 there. 1, x to the 4th, 3x cubes, 0x squareds, negative 1x's, negative 3. Under your 3's, negative 3 is where you can draw your line for your remainder. You want to drop your first term, multiply, then add. Multiply, 0 times negative 3 is 0. 0 plus 0 is 0. 0 times negative 3 is 0. Negative 1 plus 0 is negative 1. Negative 1 times negative 3 is positive 3. Negative 3 plus 3 is 0. We got a remainder of 0, so yes, it is a factor. And then they asked us to factor completely. So when we rewrite this expression, this then becomes 1 less than our original. So we have 1x cubed plus 0x squared plus 0x's minus 1. So we know that x plus 3 is a factor. We then have x cubed minus 1. I recognize that this is the difference of two perfect cubes because we can actually write 1 cubed as 1 to the third power. Our x plus 3 factor stays the same. We then need to use our difference of two perfect squares. So we have a minus b times a squared plus ab plus b squared. So my a is x, my b is 1. So I have x minus 1 times x squared plus 1x plus 1. And you just factored this polynomial completely. So for higher order polynomials, we can check factors using synthetic division to decrease our polynomial and then factor completely. Example number 4 says, during the first 5 seconds of a roller coaster ride, the function h of t equals 4t cubed minus 21t squared plus 9t plus 34. Represents the height in feet of the roller coaster after t seconds. So we know this is talking about our seconds, and this is talking about our height. So the more notes you give yourself, the better. How long is the roller coaster at or below ground level in the first 5 seconds? So first we need to understand the problem. You are given a function rule that represents the height of the roller coaster. You are asked to determine how long the roller coaster is at or below the ground during the first 5 seconds. We need to then make a plan. So we can use a graph to estimate the zeros of the function and check using the factor theorem. Then we can use the zeros to describe where the graph lies below the axis. So from the graph, 2 of the zeros appear to be at -1 and +2. The third 0 is somewhere between 4 and 5, but that one's a little bit questionable. So we can use synthetic substitution. So if we set up our synthetic problem for -21, +9, 34, we know that we have a 0 at +2 and -1, so we can use either one of those. So I'm going to use -1 for my first value. Drop your first term, multiply, add, multiply, add, multiply, add. And you can see that we in fact got 0 as our remainder, so -1 is a 0. H of -1 equals 0, so it is a factor. So if we set t equal to -1, move that -1 over to the other side, our factor would actually be t plus 1. So then we need to determine whether 2 is actually a 0. So you can continue with your synthetic division exactly where you left off. So we're going to take our answer, per se, from our previous substitution, and this time we're going to try 2. Drop your first term, multiply, add, multiply, and you can see that we got 0 again. So h of 2 equals 0. So if we set our t equal to 2, because that was our time, move our 2 over by subtracting, we can tell that another one of our factors is t minus 2. So we then have, if this one was 1 less, we would have x squared. Now we have x. So how can we find our remaining 0? Well, we can set 4x minus 17 equal to 0. Add our 17, divide by 4. So we know that our other 0 is approximately at 4.25. So this 0 right here is 4.25. They then wanted to know where our roller coaster is at or below ground level, which is between these two zeros. So we can take 4.25, we can subtract 2 from that, so 4.25 minus 2, and our roller coaster is below ground level for about 2.25 seconds.